Okay, 35 is 2 is less than y plus 6 over 2 less than 5, and full screen this, 4 minus y is greater than 5, or 4 plus y is greater than 7. So we have to do a few things here. Namely, I should get this completely as its own thing and simplified. So I want to deal with this 2 in the denominator by multiplying all three sides by a 2 to give me 4 is less than y plus 6, which is less than 10. That was effectively taking the 2 and multiplying it across all three to give me that. And then I still have the and. I don't want to lose that. Let's go ahead and make a next step on this one. I'm going to do negative 4 is greater than 1, negative y is greater than 1, and divide and get negative y is less than a negative 1. Or this will just give me y is greater than 3. So I've got that. Now we can graph these separately and try to graph them. Oh, wait, one more step here. Subtract 6, so I get negative 2 is less than y, which is less than 4. We'll slide that up. So I got all this ready to go. So this is what I'm going to graph. I'm going to do the first one on a scrap graph, then a second one, and then a final one. So I'm going to graph negative 2 is less than y, which is less than 4. I'm going to graph y is less than 1, or y is greater than 3. And the final one's going to be the and that joins them. So this first one here, well, we need to get 4 tick marks down on each of these. And maybe label them down below, negative 2, negative 1, 3, and 4. The first one's going to be between negative 2 and 4, squiggles. The next one's going to be less than negative 1, greater than 3. And that's an or, which means that it means both of them are present on the graph. So you don't have to do anything separate with that or, just realize there is no overlap, so that's legit. And then I bring them together as an and, which means the overlaps give me 2 segments. And if I convert that into set notation, it's going to be all the x values such that negative 2 is less than x, which is less than negative 1, or 3 is less than x, which is less than 4. So that's 35. Then 36 is x is less than or equal to x plus 4 over 3 plus 2, or x is greater than or equal to 2x minus 1, and 1 is less than or equal to x minus 1 over 2, which is less than or equal to 3. So I have a little bit of cleanup work to do on this. Namely, here on this part, I can multiply both sides by a 3 to give me 3x is less than or equal to, if I multiply 3 by x plus 4 over 3, I get x plus 4. Then we have to distribute the 3 to the 2 to give me 6. Specifically, you have to think about 3 as being distributed here and here. So that's good. Then we have or negative x is greater than or equal to negative 1. And multiply by 2. 2 is less than or equal to x minus 1, which is less than or equal to 6. Let's subtract the x over to this side. Get 2 is less than or equal to 10. Or x is greater than or equal to 1. And add 1, we get 3 is less than or equal to x, which is less than or equal to 7. Simplify this a little bit further. X is less than or equal to 5, or x is greater than or equal to 1. And 3 is less than or equal to x, which is less than or equal to 7. So in this problem, these overlap, which means I'm going to want to clarify what's going on with those before I do anything else. We're going to go x is less than or equal to 5, x is greater than or equal to 1, and an or 1, 5, less than or equal to 5, greater than or equal to 1. The overlap gives me, well, it's an or, so it's not overlap, it's everything on the graph. And that means that this is real numbers. So I have real numbers, and 3 is less than or equal to x, which is less than or equal to 7. So if I were to put those on a graph, I think you can see where this is going. Real numbers, 3 less than or equal to x, less than or equal to 7. And statement is my final. Real numbers is this. 3, 7 is that. But as an and, I only take the overlap, which is this region here. So that is 3 to 7. And my final is just going to be 3 is less than or equal to x is less than or equal to 7.